Okay, welcome to day 17 of extension 2, a question a day. So, n's a natural number in these. We have to decide if the statements are true or false, and if they're true, we have to give a proof, and if they're false, we have to give a counterexample. So, if n is a multiple of 9, then so is n squared. Well, that would seem obvious to me because it would have a factor of 9 in it, like say 18 is a multiple of 9, right? And if you square 18, then you're squaring 2 times 9, which is 2 squared times 9 squared. So it's 9 lots of 2 squared times 9. So clearly it's a multiple of 9. So that's definitely true. But said if it's true, you've got to give a proof. So maybe I could argue that, but not with a single example. But maybe I could try and write sentences and argue that. But I think an inductive proof might be the go here. When n equals, now let's see, it can be any multiple of 9, including 9 itself. So if n is a multiple of 9, so the first multiple of 9 is 9, when n is 1. When n equals 1, then if n is a multiple of 9, so if n is 9, that's the first multiple of 9, then n is a multiple of 9, clearly, and n squared equals 9 squared, which is 81, which equals 9 times 9, which is a multiple of 9. So this is true for n equals 9. Right? Now, got to make myself, I wish I would remember to make myself more room for these things before I begin. I'm sorry. Okay. Here we go. So we will insert a few page breaks. Okay, let's go back up. So we're in an inductive proof, and we've proven it true for the first case. Now, we need to assume it's true for n equals k. Now, i.e. that k squared equals 9 times m, where m is an integer. If k is a multiple of 9. I'm going to assume that's true. Okay. Now we want to show true that k plus 9 is the next one along. So we want to show that k plus 9 squared is a multiple. Well, we want to show that k plus, right, so the left hand side is k plus 9 squared, which is now what I should do is, what I should have done up here is, oh no, k squared is 9m, right? Yeah, so k k squared plus 18k plus 81. And k squared from above, we said k squared is 9m plus 18k plus 81 equals 9 into m plus 2k plus 9 equals 9q, where q is an integer, since q equals m plus 2k plus 9 and m, 2k and 9 are integers. So therefore, true for n equals k plus 9 if true for n equal k. And then since true for n equals 1, by the principle of mathematical induction, true for all n where n is a multiple of 9. Okay, what's part B? Part B is if n squared is a multiple of 9, then so is n. Alright. This is false. And the counterexample is, n squared, like let n equal 6. 6 squared equals 36, which is 9 times 4, so it's a multiple of 9. Therefore, 6 squared is a multiple of 9. But 6 is not a multiple of 9. So, therefore, it was false. So, there we go.